Hi, thanks for tuning in to another one of our Element Update videos. My name is Steve Hayes. I work in the Connected Technology Business Unit, and my colleague Richard Chippendale, who works in our digital engineering team. The purpose of this video really is to explain why Element offers modelling and simulation assessments. Element is known as a testing, inspection and certification company, a TIC company. So the question really is, why does Element do modelling and simulation? Richard, I'm going to put that question to you.
Yep.
Take it away.
Thank you. Well, so I guess probably the first thing to say is that Element's never going to go away from doing physical testing. That's always important for certification purposes. The power of numerical modelling is it allows us to have better insights into what's happening within our devices and often make things more cost effective for that design of that product.
Fantastic. And in terms of simulation and modelling work itself, Connected Technologies, we're in the business of helping manufacturers get their products to market. So we're looking at it very much from a, if you like, to support physical testing in that sense. But I think modelling and simulation is more than just a proxy for doing testing itself. It can be used in other areas. Do you want to just sort of explain a little bit about that?
Yeah, so wireless power transfer, or WPT, is a really interesting topic. So of course what we're really talking about here is this idea of an RF exposure of a field leaving a device and arriving at a second device, and that transfer of power to help charge that particular device. One thing we are particularly concerned about, one thing we work on here at Element, normally at the high frequency range in the testing labs, is this idea of SAR, or specific absorption rates. So here what we're concerned with is that as that energy is transmitted from the device, we want to make sure that the energy absorbed by your skin and the temperature increase that you get from that is minimal and minimized to a safe level. The reason why we've come together and the challenge that comes from that is as the industry is moving towards a lower frequency standard for this wireless power transfer, we can't do the same physical testing and certification process that we're doing currently in your labs in Element. And this is where modelling steps in, because modelling allows us to take the exact same physics, the exact same equations occurring at your high frequency end, but actually model them and understand what the process is easily in our numerical tools. So we can now understand how these low frequency devices, how they emit their energy and how the energy is absorbed into the human body to again minimize the impact that it would have on us as we use our devices.
And what about the principles then? I mean, I get the sense that what you're trying to explain is the fact that the way that you would approach modelling for heat, for example, or those thermal properties, materials sciences themselves, is similar to EM, the electromagnetic world. Is that the case?
It's the exact same concept. So it's a case of knowing the geometry, knowing the underlying equations that you want to solve, and then putting those equations into your model, onto the geometry, and then pressing compute. There is a bit more to it, there's a mesh and so forth, but fundamentally the process is identical.
And so the people that we have, certainly within Element, who work in the digital engineering team, what's typically their background then? Because it strikes me there's a combination of software that is used to do the actual simulation modelling world, but it's a very educated person that is inputting the data into that. So what sort of typical backgrounds are we talking about?
So we cover a broad spectrum of physics, everything and from mechanics to thermals to fluid flow, CFD, in the world of EM. So the backgrounds are hugely varied. Often they're people that have master's degrees or even PhDs in these given topics, so they can be an expert in how we build that particular model. But I guess it's worth just stressing that we don't just have experts in developing a numerical model, FEA type approaches, so finite element analysis approaches. We also have data scientists. So the other half is saying, well, I can't quite make that numerical model of that process. It's too advanced, it's too uncharacterized, let's say. So Baking, for example, is a very complicated multiphysics process. It's very hard to model the exact physics. So can we take measured data and can we infer some understanding, some physical reasoning from measured data? So we're also using data science techniques to learn how systems work, not from physics, but from the data that we measure in experiments, which again ties back into what Element does with all the testing processes that you have.
Fantastic.